Good morning, everyone. We'll start with a review of what we did last time and then get into understanding how you can all access your Oracle account. And then we'll get into working with basic SQL statements. So demonstrating the usage of basic SQL statements with restricting and sorting data. That's what we will end up going through for the most part today. So to focus on the first item, the review, what I want to spend a couple of minutes on is what we did last time. Last time I went through the introduction of the basic features of the database. And we didn't quite go into the details of each database type, but we talked about the different types of storage structures at a high level, trying to differentiate between flat files and database systems. The main difference between the two is that the database system has relationships, whereas flat files do not. We talked about the problems that can occur as you work with flat files. So when you work with flat files, one of the things that comes up is because there is no link or relationship between each file, what can happen is there can be data inconsistency. And each program that runs on top of the flat file has to manage or be accountable for the data inconsistency. As a result, when we work with database systems with relationships, we end up with the notion of referential integrity, a definition that I asked all of you to write. So we create these logical links between different files. We introduced the concept of a primary key and a foreign key. Primary key is a unique identifier inside a table, and that primary key, what it does is it provides you with also a index that's automatically created every time a primary key is assigned inside a database, and it also gives you a unique value for each record. Then we use that primary key as a foreign key to reference the records. For example, in the order table, when we use customer ID, then we can get the name and address. We can get the name and address of the customer from the customer table for each order. The other nice thing is that when you make changes in the structure of a table, no changes have to be made in the programs that are running on top of the database, because the relationship management is taken care of by the database. I also introduced you to the basic DML statements: select, insert, update, and delete. So we kind of walked through all of these statements. I'm not going to go through them right now. And then we talked about the basics of the database architecture, the fact that there are physical files and there is an instance which is a set of memory and processes to run the database files. This talks about how the database table is accessed and used. Essentially, a database user named Paul in this case can initiate a query into a table. It will go and retrieve the information from the database, bring the results into memory, and show it in a very nice report. So you interact with the physical structure through the logical ones. So we're going to look at processes and memory as means of interaction with the database. So here we have employee table and department table. So the employee table and the department table have their primary keys referred to as PK, and foreign keys is referring to the department ID. Foreign key always refers a primary key. In this case, we are creating a link between department ID of employee table to department ID of department table. By having this linkage, we can say that Durand works in department 30, which essentially means sales. We can also see Khan works in department 40, which is in operations. So primary key and foreign key relationship. We also talked about the concept of an index, which refers to creating a table with employee ID and row IDs. This works very similar to the index in the back of the book. So we can have easy and fast access to specific rows in the database. Then we have procedural objects that refers to essentially programs that are written to access the data from the database to produce reports or other transactional output, like inserting a database, updating a database, etc. So SQL is what you're going to end up learning in this course. You already have a start, and the next thing is, well, how do I access the database? So the first thing you have to do is create a Unix account. So to create your Unix account, you follow these instructions. It's a very simple process that can be done online without having to go to the lab. It can just be done online. Then to log into the Unix account, I've written instructions for Windows users and also Mac users. And then there's also a little video that I've provided a link to that you can watch to see how to access. For Windows, since I'm also using Windows, I'm going to be using a program called Putty. This is a client program that is going to allow me to access the database. So what I can do is simply go on a search site and just search for the word Putty. I can download Putty right here and just get the executable, the putty.exe that you just saw me download. I'll go ahead and open that right now. You can of course put the executable on your desktop if you so choose. That actually might be a little handy thing to do. So in the host name, you can type voyager.dianza.edu and leave the port number as 22. And usually what I'll do is, I'll click on save. Like I'll give this, so I don't have to type it again and again. I'll give this guy a name, a session name, and I'll save it. So then I'll end up with this. So if I click on open at this point, then you see the screen. So let me go ahead and change the settings so the font size is visible. So I am going to log in as myself with the login ID. And there I am. I'm now logged into the Unix prompt. If you have forgotten your Voyager password, then you can send me an email and I'll connect you with the Unix administrator and get your password reset. That was, I think, a question that was just asked in the chat room. I'll be happy to assist with that. So now we are ready to log into SQL. So we'll say SQL plus, and we will say we'll enter a SQL user name and then the password. And now you are logged in as a SQL user. Each one of you have been added to the I've added all class members to a Piazza site. If you don't have, this is basically a discussion group for if you have any question. So if you don't have access, please let me know. And I'll be glad to give you access. So you can send an email to me at this email address. I've also sent the class login ID information and password information. So you should have a SQL user account that you all can use with the password. And you can download, then you can use this process that I use to log in. Is there, for Unix account, if you're getting denied access message, then most likely you don't have the right password. So in that case, you can follow up with an email and I'll connect you, like I said, to the other person. I can connect you with the database administrator or the Unix system administrator and they can reset your password for you. So, are there any other questions on system access for now? Like logging into both Unix account and Oracle account. I'll just wait a minute in case anybody does, and then I'll go ahead and start our next topic of working with the SQL statement, or the select statement as we call it. The temporary password that I provided you, it would be a really good idea, in fact, to change that. So the way you can, good question actually, how to reset the Oracle password. Since you choose your own Unix password, obviously you don't need to change that, but you can say alter user and then we say username identified by password. And password will essentially be the new password you come up with. Does that answer that question, the last one? Okay, perfect. So we'll keep any other questions from anyone? So if none, I'll go ahead and start with talking about the SQL statements. Okay, so working with the SQL statement. How do you get these lecture slides? They're on the website. Just, as you can see, I can download these from the website. I download them from the website for lecture purposes, so can you. So all these notes are nicely linked, so when you mouse over, that's what you get. Okay, so let's go ahead and get started. So what we're going to be doing today is talking about restricting data with the where clause, which means when we work with the where clause, we can use all these different operators. Working with arithmetic expressions, operators, null value and where clause, and then we have group by and order by clause. So this is how the where clause works. We have to first use the select statement. So I'm going to be demonstrating as we go along. When we say select star from EMP, the star is going to bring out all the columns from the employee table. So right now you can see that I tried to do a select and it says table or view doesn't exist, which means I cannot there's nothing in my database. So what I need to do is go to assignment 2 and run a small script. So you see this says run the following script to set up the database and then write queries. Does everyone see that? So this is also a hyperlink. If you click on it, it's going to download a text file for you. So you can see the text file. What I'm doing is selecting everything in the script. So I'll say edit, select all, and I'm just going to copy it. And then I'll go to my Putty window or my window where I have the database. I'm just going to right click. And what it did was it pasted, when I did a right click, it pasted everything in for my database. This is a quick way of running the database, if you all understand what I'm trying to say. So at this point, my database has been installed. So if I go in and say select star from EMP, you're going to see that I've got 14 rows selected. So I've got 14 employees in my employee database. This was the statement I executed. Now I'm getting the header every 3 rows. So the way the SQL statement is executed, it throws the header and then it throws certain number of lines. So I can control in my formatting, I can run some commands to control the formatting of this page. I'm not going to do that. I'm not going to change anything at this minute or at this point in time in terms of formatting, but just expect that this kind of formatting is okay for submission for the first few lab assignments, because we'll be going through that process in learning that process over time. Everyone clear on how to submit submit the SQL statements to create your database? It's a simple copy and paste from the text file that you download from this link right here, where it says run the following script under assignment 2, and then you take the text file. I copied this and pasted it into here. Does that make sense, everyone? Any questions? Okay, so now that I have my select statement, I have my database, I can start talking about the details. So now when I say select star from table, star essentially refers to selecting all the columns in the database. And if I don't provide a where clause, like in this case I did not, then I'm getting all the rows as well. So and now if I say the where clause, then I have to provide a condition. So condition can be salary is greater than 1,000. So everyone that has salary greater than 1,000 should have been selected with this. But now it's saying, well, you're missing the left parentheses in the where clause. So whenever we write conditions, we have to make sure that we put those in parentheses. Something like this. So we'll say select star from EMP where salary is greater than 1,000. So there were two mistakes in this. One, the table named table doesn't exist, and the other, I did not use brackets. So we need to put parentheses around here. And then run our select statement. So now I have 12 rows that were selected with folks that have salary greater than 1,000. So as you can see, I still said select star from EMP. Now, if I end up typing my select statement at a prompt here, and if I make a mistake, then there are certain things one has to do to go back and edit line by line, right? That is learning this interface, which is called the SQL Plus. But until we do that, a good thing for you all to do might be to just use a text editor and copy and paste from here. So you can copy using Control-C and paste using the right click. So another statement I want to show you is looking at all the columns a table may have. And that is describing the table. So you can see that this table has 8 columns. These are all the columns that cannot be null. Employee number, and department number. Employee number is in fact our primary key and department number is our foreign key. And I can also see the data types of some of these columns, like how a number is represented, how a date is represented, and how a string is represented. So when you see number 7,2, that means it's trying to save a value with a precision of 2. If you see a number with a value of just 4, that means it's a whole number of size 4. That's how the data type sizing works with the employee table, with the different data types, I mean. Okay? Everyone can hear me okay and can still see the desktop? Okay. So now the next thing would be if I wanted to select specific columns. So if I wanted to say select employee number, employee name, and their department number, then I can specify the columns that I want and see what happened here. I put a colon at the end, which was a mistake because the colon will end the line. So I just wanted you all to see what the reaction is from the database. When I put a colon in the end, it says error in line 1 from keyword not found. So now if I hit enter and it says unknown command from EMP because that was in the second line. So there we have it. We have all the 5 columns that we selected, and we only have 14 employees in the table. So, you know, that's the result we get. So I hope this makes sense in that when you start with the select statement, we can use the where clause to remove unwanted data from a query result set. We can also use the where clause for modifying one or more rows. And if we are also selecting data from more than one table, then we can use the where clause to bring data from more than one table in a single query. The concept of bringing data from more than one table is called a join. We'll talk about joins next week. For today, we're only going to focus on getting data that we want or filtering out unwanted data from the query result set. This is how the basics of the where clause work. We have select column name from table, and then we have salaries greater than 3,000. So let's try that out. We can just say that where salary is greater than 3,000. And it only brings out one person, the president. So if we say how many people have salary greater than 2,000, so you can see when I type, when I paste the query it puts number 2 and number 3 in the end. The reason for that is because I've got 3 rows in my query. When I paste it all in one line, but then it identifies that there are 3 lines. You can ignore that. When you hit enter, it's going to return whatever rows pertain to that query. So I can see the salary as well. Then I can add salary into this. So now it's pretty clear when who has salary of 3,000 or higher or 2,000 or higher. Okay. So this is the part which we can more likely try and ignore for now. We can say that we'll deal with selecting data from more than one table down the road. Oh, you mean using this for conditions? It's actually optional. But because I had given an unknown table name is the reason I got that error. But as a coding practice, I generally try and bring that to your attention with this kind of a citing to form good habits from the future. From the beginning, I mean, to formulate good habits from the very beginning. Okay? Make sense? Okay. So just to demonstrate, and of course I'll paste these notes for you guys online in the discussion board. So if I go ahead and say that I'm going to select data from 2 tables. Let's go ahead and verify the column name. So we'll select the department name. And when I select, all the rows, when I select all the rows from department table, and I select all the rows from the employee table, I get 14 rows and 4 rows. So when I select data from both tables, let's see what happens. It gives me 56 rows. This is called a Cartesian product. So what it's doing is, it's putting every employee in every department. Let me demonstrate. So look at Scott. He's in accounting. Then we look at Scott again. He's in research. Then let's look at Scott again, and now he's in sales. And then we look at Scott again, and he's in operations. So what it's doing is, this is like multiplying 2 sets. So this becomes a Cartesian product. I'll talk more about this in the next lecture when I introduce you to joins. With the where clause, you can specify 2 conditions. You can specify actually n conditions. using the AND operator or the OR operator. But each condition, as they say, is evaluated separately. But when we use the OR operator or the AND operator, we take the results and compute the output accordingly. Now, when we use an AND condition, this condition should be true for each row, and the second condition should be true for each row for it to be included in the result set, which means that we're only going to get employee number 7566 with salary of 3,000, greater than equal to 3,000. That's the notion of the AND operator. So if I were to take this query, so one of the things I'll do is paste it for us for our notes, so you all can try these out. So you can try these out separately, Make sure that every time you put a semicolon in the end. And it tells me no rows selected. So if I wanted to do my own little investigation, I can in fact look at the result above and see salary that 7566 has is in fact less than 3,000. That's why it said no row selected. So what can I do? I can change my query to say 2,900 and execute it again. And now you can see that I get that employee Jones, whose salary is 2,975. And because I said that in the query that the value should be greater than 2,900. So the row shows up. So what we are doing is using the where clause with two conditions. And there's no limit to the number of conditions that can be specified. So condition is comprised of one or more expressions with one or more operator, generally speaking. So expressions can include numbers, columns, literals are values like 10 and 20, subqueries or functions. And operators can be all these: arithmetic, comparison, character, logical, in and between. We're going to look at each one of these each one of these we're going to look at separately. Now, importing data from Excel sheet through this command interface is not possible. You have to write insert statements to bring in data into the database. So you have to, it won't even be in text format. It will be in, it will be a series of insert statements that will need to be added. So I hope that answers your question. Something like this, like now we are looking at the usage of the where clause with an update statement. So we say update table name, set salary to 3,000 for employee number 7566. So let's actually go ahead and execute this. After I do a update, I should say commit. And when I say commit, then the value is selected. Now if I say select employee which has salary greater than or equal to 3,000, then the result will show up. That's how it looks. We can also use an update statement like this and put a subquery in it. So like we can select the data that returns one value and then put that, we'll execute this highlighted query first. We will get the data and then we will say where employee number is equal to. So here subquery is used in the where clause and mtable is updated to reflect the new salary. Any questions on usage of the where clause in the update statement? Everyone can hear me okay? All right. So we'll keep going. We're going to bring in arithmetic operations. These are generally used on the column types that are either number or date. Earlier I showed you how to describe a table and look at the data types of each column. So if the column type is either a number or a date, then arithmetic operators can be used. So generally arithmetic operators are used for different types of calculations. Addition, subtraction, division, multiplication, modulus, and so on. So how are these operators used? So if I wanted to perhaps add a salary or add a value to the salary to show, then I can use the arithmetic operators for that purpose. So in other words, I can say select sal plus 500 comma sal from EMP. So you see in the result what happened was it is showing me a what if situation. If I added $500 to everyone's salary, what would that look like? So just an example of the usage of the arithmetic operators with select statement. You can either use those in the when you in fact select a value like I did here, or you can also put it in the where clause as it's shown here, where if low sal was a column in the employee table, which it is not, by the way. Then that's what happens. That's how we interpret and use the arithmetic operators within the where clause. So If any of you have done any programming before, you might be familiar with the concept of operator precedence. But if you haven't, not to worry. This is borrowed from arithmetic actually. So precedence refers to the order in which the operators are evaluated if I don't end up using parentheses. If I use parentheses, I can use that to enforce priority. So there are, in addition to arithmetic operators, there are all these other operators we have to look at. Comparison. So let's look at each one of these like separately. I mean, I don't want you guys to get overwhelmed with a big old list, but let's get to know these one by one. So single row operators are these. This is the equality greater than, equal to, less than, and less than equal to. You of course need to provide two values for, this. Then we have the is null operator. And then we have in, any, and all. We have these three operators. These are multiple row operators. The multiple row operators we are going to focus on in another lecture. Although I might do a small introduction today, but you're not expected to know these right away. But the basic operators, the single row operators, because we are working with, when we are selecting data and we write a where clause with a select statement, I think I just want to help you understand what I mean by single row operators. So when I say something like this is if I have 14 rows in the employee table, that condition sal greater than 2000 is going to be applied 14 times, one for each row. Make sense? So okay, so these are also called relational operators. And then when we start saying multiple row operators using in, any, and all, that means that multiple rows will be involved in each condition check. So, okay. So here is the single row operator usage. Select ename from EMP where sal is greater than 4000. Please take note, this is the not equal to operator. Then we have the is null operator. So null value is something that is unavailable or an unassigned value. So let's have a look at some null values. So if I were to say select employee number, employee name, salary and commission. You can see clearly here that several employees do not have a commission. So when an employee does not have a commission value assigned to it, then that is what we are talking about. So let me bring down that statement for our reference. So this is if I wanted to execute this statement like this, that if I wanted to say where commission is null or commission is equal to null, then it says no row selected. Because if I try and get those null values that I showed you earlier, it's not going to work. So, but if I say where commission is null like this, then it will work. So I've got 10 employees that don't have any commission value. So I hope you can see the difference on saying commission is equal to null versus using is null. Is null is considered to be an operator that is meant to be used with null values. And that's what this slide is trying to get across. We have a definition of what a null value would be and what this is. So okay. So this is hopefully giving you some tools at your disposal to try and play with. The best thing in my opinion to do is to play with these SQL statements with the different examples, so you can practice and get acquainted with a lot of what is being covered here. Now we have the multiple row operators in, any, and all. So in this case, we are saying we're trying to compare the value of ename with two values. So this will be like writing two statements. We say ename equal to King or ename is equal to James. Here we are doing a gentle intro of any operator. So please note that with the any operator, we bring in relational operators. So we say salary is greater than any of these. So again, the same idea that we take the value of salary and compare it with two values instead of one. That's the value proposition of working with multiple row operators. Here we say salary is greater than all of these three, 4, 3, and 2. So we'll cover multiple row operators in depth in another lecture as we get more comfortable with the select statement. So this one is an important one. This is an operator that is used with strings, and this is to concatenate two values. So here what we are doing is saying, let's take the value of employee name and concatenate it with single quotes and a comma. So inside the single quotes we have a comma and one space. Then we say concatenate that with employee number. And then we put in double quotes what the heading should be for this column. You might have noticed earlier that when I don't specify the header name, it is basically the column name in the database. But if I want to customize the column name or the header I mean, then I can specify that using the double quotes. Otherwise, when I'm specifying values for concatenation, those I put in single quotes. So we can use equality with strings, but we can do some pattern matching, if you will, using the like operator. So here we are saying select ename from employee where ename like J%. And what that means is percent refers to, percent is a wildcard for a set of characters. So what you see here is anything that starts with the letter J, and if we have 3 characters or 10 characters preceding, it's fine. We'll just select all of them. So in this case we get Jones and James, which happen to be the same number of characters. So we can also use an underscore, which is to match one character at a time. So all the names that end with ing, but we are only going to allow usage of one character before that. If I had said %ing, then names like king, baking, then those would all be selected. But the fact that I'm using an underscore, then names like king, one letter K, Bing, one letter B, would be selected. Okay. We can use combination of percent and underscores together. So in this case, we are using an escape option. So what if whatever I'm trying to select actually has whatever I'm trying to select has an underscore in the data itself. So what I'm doing here is I'm saying, okay, I want to select everything before so this is a wildcard for n characters. This is another wildcard for n characters. And this is backslash underscore. So this particular character, I'm basically saying that I'm using the backslash as an escape character. So I could have said question mark here. Sorry, let me enable the editing for this. Right. So if I go in and say question mark here and I say escape question mark, that would mean the same thing. So if I am trying to get one letter as an underscore that is in the string I want to select, then this is the way to do it. So this percent sign means all the characters after the underscore, and this means all the characters before the underscore. Slides 21, 22, and 23 must be practiced. This is like, you know, I mean, it's one thing to look at something, but it's another that if you, it's another thing if you get to practice it, then you'll know it better. Then we have logical operators. And or not. So with the AND operator, we will have two conditions. And for each row, both of these conditions should be true for the result to be selected. So in this case, you're going to see that when the name starts with S and salary is equal to 3,000, when both of those conditions are true, then the result would be selected. You can also use the OR operator. So then that means either the name starts with S or the salary is greater than 3,000. And not is the inverse. So we can say when the department is not 20 or 40, so application of logical operators in the queries. So the rules for the order in which the operators are evaluated, we evaluate not, and or in that order. But if you don't want to remember any of this, you can just use parentheses to override the default rules. So just to reiterate how and or operators work. So basically when both conditions are true, the result is true, and when both conditions are false, the result is false. This is how it works with parentheses. So whatever is in parentheses is executed first and then evaluated with the rest. So in this case, for example, we will say true or false is true, and then true and true is true. Let's take one more. False or true is true, and we take the result of that and we say true and false is false. So go through slides 30 and 31 as well. Again, any of these things I'm asking you to do are not things that you have to submit, but try out. So, how's everyone doing? Any questions so far as we tread along on these topics? Is everyone doing okay? All right. The next thing we are going to look at is the in and between operator. So in operator we talked about already, which basically takes a set of values and does the comparison. So we say where department number in, and we're going to compare the value of each department number in the row with 20 and 30. So these operations can be fairly expensive in the sense that each, if you say have 5 values in that set, then we're going to do 5 comparisons for each row, which will make things slow. Here is the between operator. So when we say between 3 and 4,000, then 3 and 4 are both included. So it's inclusive of 3,000 and 4,000. Here's a little bit on null values. Null values are unavailable, unassigned, unknown, or inapplicable. See, by the time you're done with this course, you're going to learn a lot about null values. So I would recommend creating some notes in one area about null values as you prepare for the test. Null values are not the same as 0 or a space. 0 is actually a number and space is a character. If a column of any data type can contain null values, then it will not have the not null constraint. But if it can, then we will give it the not null constraint if it cannot have null value. Another thing you can do is using the primary key. Whenever we use the primary key, we never get null value in that, because if you end up with a primary key column, then those values cannot be null at all. If any column in an arithmetic expression uses a null, the result will always become null. Like when you divide by 0, you get an error. When you divide by null, the result is either null or unknown. So the other important thing is that we don't use equality operator for comparing nulls. We use the is null operator. So something like this. That was shown earlier. This cannot be done. Like if we say commission is equal to null, that will not work. Like you won't get any errors, but So what we have done today is we have gone through this part of the select statement, and we have tried to basically learn the where clause in today's work. What we still need to do is spend time on group by, having, and order by, and we'll do that in the near future, in one of the future lectures. So like, some of the slides that follow try to show group by. I think we can pretty much ignore group by today. It will just be unnecessary digression. But the order by clause is used to sort the data. This is actually interesting. You can sort data by multiple columns, and you can also control the order of each column. the default order is ascending, but if you want the data sorted descending, then you should say descending. And so the way the ascending descending part works, let's demonstrate that for you guys. So let's say we take this column, and then we can say order by employee number, or we can say order by salary descending, comma, employee number ascending. So this is like when you go in Excel and try to sort data, this is the same thing, except we are doing it in okay, so I guess I forgot order by. That was a mistake on my end. So we can say order by. We'll take that result and again can only have one semicolon. So employee number is employee number, EM, like the column name was wrong, so it just gave a syntax error for that. So now you can see that when we look at salary, it's in descending order, starting with 5,000 all the way down. But the employee number is in ascending order. So if you actually take a look at these three values, salary in descending order is the same, but the employee IDs for those three are in ascending. Okay, so that's the order by clause. So now I think you're game for assignment number 2, and assignment number 2 is asking you to write a bunch of queries for these questions, and this is all on that database that we created at the outset. You're going to use the same script for the entire course. Okay, you're going to use the same script for the entire course, all the tables that are already created the first time around. So what you can do is, for submitting your work, so this is what I require for homework submission. So create a text file with first question number, the description of the question, then put the solution, and then a test run. And then you can go and do the same thing for question 2. Am I making sense? So you can submit essentially one text file with all this information. Question number, solution, test run. Question number, solution, test run. So So if you're able to do this, then we have our the outcome for the lab 2, and I think I talked about submitting labs last time. You emailed those to cislabs05@gmail.com. And do most of you or all of you in the room have access to the do all of you have access to the discussion board that I talked about earlier on Piazza? If not, please be sure to email me. And you can just copy and paste the solution into a text file and we're done. Yes, that sounds good, Ronnie. Any other questions from anyone? All right, guys, this is all for today. I will see you all next time. How you can change the Excel data to preferred format? Sure, we can talk about that. I'll be here. So let me go ahead and stop the recording and see you all next Tuesday, everyone. Take care.